This lesson is about optimization or a maximum or minimum story. So the story revolves around finding a maximum value or a minimum value, and the big idea is to come up with an equation, take the derivative equal to 0, solve it, make sure it's a maximum or minimum. So we're going to do that right now. So number one, a box with no lid is to be made from 48 centimeters squared. If the box must have a square base, find the dimensions that produce a maximum volume and explain the meaning of the answer with a complete sentence. Here we go. So I want to find the dimensions that produce a maximum volume for this box. This box has a square base. I don't know what the length of the square is, but I know the two sides must be the same if it's a square. So there's my base, and then the box has a height. I know volume is length times width times height. So length times width times height. So that's x squared times h. Next, I have too many variables on the right side. So I'm going to take the first sentence. The material is 48 centimeters squared. Now, the material used would be the area of each face of this box. So the bottom of the box, the area of it, is x squared. The sides of the box, the faces that make the side, are rectangles. In each rectangle, the area is x times h. And if you count, how many rectangles do you have that make the faces? There are 4 of them. This represents the entire area of the box and how much material you need. So we're going to make that equal to 48. Next, we're going to solve for h. So I'm going to subtract x squared, and I'm going to divide everything by 4x. And then, once I know what h equals, this is what h equals. I'm going to go back here, and then instead of h, I'm going to put this in for h. So this is what h equals. So I take h and I put that in. Now I only have one variable, and now we're in a better place to take the derivative equal to 0 and solve it. I'm going to distribute here. That's 48 x squared minus x to the 4th over 4x. And then I'm going to make it even better. I'm going to write this as 2 fractions. So 48x squared over 4x minus x to the 4th over 4x. So I'm trying to make it as easy as possible to take the derivative. So 48 divided by 4 is 12, and x squared divided by x is x. Here, that's negative a quarter. And then x to the 4th divided by x would be negative a quarter x to the 3rd. That is now easiest to take the derivative, then equal to 0, and solve it. So the derivative here is 12. 3 times a quarter is negative 3/4, and then subtract 1 to the exponent. What we want to do is find a maximum answer. We want to find that turning point. So we're going to take the derivative equal to 0 to find a maximum value. I'm going to add the fraction to the right side. I'm going to multiply by the reciprocal to undo it. 3 goes into 12 4 times, and 4 times 4 is 16. And then I'm going to square root. So x is equal to 4. I'm going to confirm that 4, we can't have a negative answer, so 0 on. I'm going to confirm using the derivative. So if I plug in positive 1 into the derivative, I get a positive answer. If I plug in like 5 or 6 or 7 or 10, I'll get a negative bigger than 12, so that you get a negative answer. So it's important to know that 4 gives you a maximum answer. So that's what I'm looking for. So the question again asks for the dimensions. So right now we know x is 4 centimeters. I still need to find the height. So to find the height, I use this formula right here. Put in 4 for x and solve it. So 48 take away 16 is 32, divided by 16 is 2. So what dimensions produce a box with maximum volume? And it's 4 centimeters by 4 centimeters by 2 centimeters. So that size of box produces a maximum volume. Number 2. So again, these are maximum and minimum problems or stories. So we're going to read a story. We need to come up with an equation. Take the derivative equal to 0, solve it, make sure it's a maximum or minimum, and then there's your answer. The sum of two non-negative numbers is 30. Find both numbers if the sum of twice the first plus the square of the second is a maximum. So this story is about two non-negative numbers. So we got x is going to be the first number. We'll let y be the second number. The question says find both numbers if the sum of twice the first plus the square of the second is a maximum. So I'm just going to make that equal to m. So I want to know what the maximum value is there. And then the first sentence, we have too many variables here. The first sentence says the sum of two non-negative numbers is 30. Now, I have a choice. If I solve for y and I plug in, I'm going to have to square it. I'm going to have to FOIL. That'll be a little more work. If I solve for x by subtracting y, it'll make it a lot easier to take the derivative. I'm going to distribute, and then this is a lot easier. I could FOIL easily too. Both will give you the same answer at the end, but this is an easier way to get there. So now we have an equation. What are we going to do? Take the derivative equal to 0 and then solve it. So if we solve this, y is equal to positive 1. At this step, we're going to draw a number line. Now, my numbers are from 0 to 30 only. So y can be from 0 to 30. So 0 is a non-negative number, the smallest one. And then y 30. Well, if y was bigger than 30, well then x would be a negative answer. So they have to add up to 30. So if they both are non-negatives, both numbers must be between 0 and 30. Otherwise, one of the numbers would have to be negative. So it's between 0 and 30. Put 1 there on the number line for the derivative. So remember, this is your derivative. If I put 1/2 in for y, 2 times 1/2 is 1, and negative 2 plus 1 is a negative answer. If I put a number between 1 and 30, like 10 or 20, I get a positive answer. What I found was, at positive 1 is a minimum, but I'm looking for a maximum. So positive 1 is not my answer, because it doesn't give me a maximum. Instead, it gives me a minimum. So now what do? I now look at the ends of my domain restriction. I'm going to do a table. And in my table, I have the first number, the last number, and my formula, which is 2x plus y squared. The end possibilities are this. X could be 0, and then y is 30, because they have to add up to 30. Or x is 30, and y is 0. Those are my possibilities at the ends that I'm going to test. So in the middle, it doesn't work. It's a minimum. So the answer is going to be at one of the ends that give me a maximum answer. So plug in 0 for x and 30 for y, and you get 30 squared, which is 900. Plug in 30 for x and 0 for y, and you get the answer 60. Which of these is the maximum answer? So when x is equal to 0 and y is equal to 30, it produces a maximum answer. So when x is 0 and y is 30, that we get a maximum answer that way. What is the minimum? Well, 1 is the minimum. So when x is 1 and y is 29, so when x is 1 and y is 29, oh sorry, I flipped it around, didn't I? This represents the y value. So make sure I understand that, right? Because I'm like the y value. So when the y value is 1 and the x value is 29. So when the first number is 29 and the second number is 1, it produces a minimum answer or a minimum value. So when the first number is 29 and the second number is 1, it produces a minimum value. All right, there's your lesson on optimization. These are stories to do with maximums and minimums. Mr. G Math over and out until we will do our assignment next.